Hello everyone, in this video we are trying to follow this book Cloud-Based Remote Sensing with Google Earth Engine, chapter A1.7 Humanitarian Applications. In this chapter we learn to visualize and document the land cover changes that have taken place. We learn to use satellite data to estimate the settlement's boundary and compare it to the official boundary laid out by the United Nations High Commissioner for Refugees. And we learn to use satellite-derived demographic products to estimate the refugee population within Tanzania. So this Tanzania is somewhere located in Uganda. To highlight this chapter is very nice, and I would rate this 10 out of 10 because so many things are covered in this chapter, and this has this unique approach of everything. So this is much helpful, very much helpful for learners like us. So we will try to go through the codes. So here we begin with map.set options, and this selects the satellite display in the maps here. And then we have this story area, and then we are adding this as the layer by map.add-layer. We see this variable name. Then we have these two curly brackets inside which usually the visualization parameter goes. Then we have this name of that layer, and then we have this function map.center object, and this just zooms that study area, and here the zoom level is 14. After that we have this buffer size variable assigned with the value 500. So this is in meters. So what we're doing is we are creating that outer boundary for that study area with the buffer size of 500, meaning the width of that buffer will be 500, and this dot bounds dot geometry considers the whole buffer and the study area as the new geometry. After that we have this function, very nice function here. So function add indices. So this function will take the image. This is the image we will taken, and then from the image we will have the different vegetation indices being calculated. So the first one here is the NDVI. So this will take the NIR and rate, and this is renamed as NDVI. So this is the way to rename here, and this is being repeated 3 times with 3 different bands, and each time this will be added to the original image, and we will return the image with 3 different bands added to that image. So very nice function here. After that we have here Landsat 8-band names. So these are the default names. We see them when we have the surface reflectance collection 2. So this SR means surface reflectance, and then we have this Landsat 8-band rename, blue, green, red, and others. So what we're doing is we want to rename the default Landsat 8-band names to this readable words. So here we see this Landsat 8 surface reflectance. So this is the unique string for this dataset or for this image collection, and then here we are filtering with 2 different dates from 2015 to 2020, and then we are filtering. We are doing this filter bounds just to get the images within the study area, now the buffered area, and then we are also doing this filter for the metadata. So we do this cloud cover. We want to have the cloud cover as less than 40%. So this .lt means less than. So there are different operators in Earth Engine, and this .lt is one of them. And then here we are selecting the Landsat 8 band names, and so this .select not only selects the bands but also renames the bands. So here this is the Landsat 8 band names from here, and then we have this Landsat 8 band renames. So this is renaming the bands to the new names. And finally we are adding that function .map at indices that was created earlier, adding 3 different vegetation indices, and this whole Landsat 8 surface reflectant is being resulted as the new image collection. So this is the nice thing being done here with filtering with our study area, filtering the dates, filtering the cloud cover, selecting the band names and renaming it, and then adding the 3 different vegetation indices. Then we have the this pre-median variable. So what is being considered is the 2015. The year 2015 is being considered as the year when the settlement has not taken place in that area, and the 2017 is being considered as the year when the settlement has occurred. So here we are filtering the date for 2015. So this whole year is being taken, and then here we see this dot median. So this dot median gives us that single image, and by single image we mean doing all the median calculation of all those images present within those months, or within those time gap, or within those year, and then we are clipping it with our study area just to make that image appear inside of that study area. And this has been repeated for 2017 as well. And then we see this palettes here. So this require is the function that helps to get the codes that are already written by some other users maybe, and we want to get those functions that are already written for this script. And for this case, this is the package is called palettes, and from that package we are selecting the 2 different colors. So for the first one is the green, and second one is also the green. So generally these are the 2 different color to be used for the visualization. Then we see this true color image visualization parameter. So we are making this visualization parameters for the images. So this is for the true color, and here inside the bands we have the red, green and blue. So this is the true color like what we see usually. And then we have this gamma, maximum and minimum values, opacity, and again these values can change depending on what we want, and so these are some values that can change and we can play around with these values. And then we have this false color visualization parameters, same thing as before, but this time we're using NIR, red and green. And then we have this gamma values, minimum and maximum, opacity, and these values can change as well. Then we are adding this two images. So this is first one is the pre-median image with this true color image visualization parameters, then followed by the name of that layer. Same thing for the post-median image, this visualization parameters and then the name of that layer. Similarly, we do the things for the false color images. First one is the pre-median, second one is the post-median, and here we have the different visualization parameters. And we're also adding the NDVI, and for that we have this pre-median, but this time we are selecting the bands as NDVI. Then we have the minimum and maximum values, the values of NDVI, is from -1 to +1, and then here we are using that palette that we retrieved from that require. So these are the palettes already created somewhere else, and we are using this for our purpose. And we are also doing this for the post median, and here is the same thing, just the name is different. And then we are creating this empty image. So this empty image is being created for the display of that outer layer. So here, this empty image, in this empty image, we are painting. This is being done by .paint, and in the feature collection, we have our study area, and then we have the color and white. So this is just for the visual display of that study area, it's making it a little appealing. And then we are adding that as the new layer. We will see this when we see the layers. Then we are also doing the subtraction of two different images. So here, like the mathematics, we are doing post median dot subtract pre-median. So we are subtracting one image from the other image, and that different image is being added as the layer again. And in this case, we are using the different palettes. The band name is the same, and the name of that layer has been provided. And then we are also doing something here. So we are selecting the NDVI from the pre-median image and renaming it as pre-NDVI, and we are adding the bands with the post-median image, selecting the NDVI from the post-median and then renaming it as post-NDVI. And here is this nice function called ui.chart.image.histogram, and this function gives us that histogram, and the histogram is just to see which values are maximum or which values are in large numbers in that study area. So here we're creating that chart, and so these other things are just for more information for that chart, such as the title. We have the title for horizontal axis, we have the vertical axis and the title as count, and some colors for two different histograms, and then we are printing that chart. And the last thing here, we are doing this video or the GIF image. So for that, we can use this require, and there is this packages called text, and for that, for the visualization parameters, we are again using this red, green, and blue. We have the gamma values, maximum and minimum, and opacity. Then we have this video arguments with the region as our buffered bounds, then the frames per second, how the GIF image will move from in the time frame, and then we have the scale, and then we have these annotations to make the date, where to make those dates appear. And here we have this function add text, a very useful function. So this might be useful for our case as well when we want to make such GIF images. So inside this function, we have the image, and here we have the date properties being selected from the image. So from that image, we are getting the time start properties, and this time start properties is being formatted into year, month, and date, and this is being converted as the string here, and that string is now inside date. And for that image, we are clipping that image with our buffered area, and then we are visualizing it with the with that visualization parameters, and we are providing, or we are giving that new time properties to that image by .set. And then here finally we use that function just we called before, and then this is followed by dot and not image, and then we have the image, and then we have the buffered bounds. So these are just the creation of the new image with the level or the date is being added to that image. So the dates are just overlaid to the image. We are just pasting that string to the image. And then here we are doing this dot map. So for this is being done for all the images present within the image collection. And finally we can print that out by dot get video thumb URL, and this can be seen here. So we will see the layers here. So we will quickly go through the layers. So I had already done this, so we will see this. This is the stereo area, so we can see this area here, and then we have the median image. So this is the pre-establishment median image, that is from the year 2015. Then we also have the image from 2015. So these are the true color image, and we can see, we can certainly see some brightness in the year 2017, which is very different from 2015. Then we have the false color image for 2015, and then we have the false color image for 2017. So certainly we can see, so these red colors are generally related with the plants or vegetation, just a way to see the plants. And then we have the NDVI, and then we also have the post-establishment median NDVI, so which is much wider than the pre-establishment median NDVI. Then we have this boundary layer, which we had created by creating that empty image, and that in that empty image we had painted with this. So this is just for the visualization. And then we also have this difference image. So we see some difference image. For the interpretation of this difference image is that if the values are near to 0, there is no change, but if the values are slightly negative or higher, some changes might have taken place. So that's the general concept for this difference image. And in the console we have the frequency histogram. In the frequency histogram, what we see, so this is for the pre-establishment. So in the pre-establishment time, so the values are 0.24. For example, this value 0.24 is in the large number, meaning this in the area 0.24 is the value that is present in the maximum number. And in the year or the post-establishment image, the 0.14 is the values that is found in higher number. So this certainly says that there has been some kind of decrease in the values of NDVI, meaning there has been some changes. We can certainly say there has been the difference between those two time frames. And then we have the time series video, and what this does is, if you click this, what we see, or what this is doing here, is the display of the image. So the images are moving very rapidly, and we can see the dates here at the very top. And if we see very closely, what we see in the later years in 2018 or in 2020, there is some stripes or patterns like that here in somewhere, yes, in somewhere in 2016, in 2017 or 2016, 2017, there is some patterns being created. Maybe we can interpret that as some signs of settlements. So this is the first section. Then we move to the section 2, again, I have already run this. So in the section 2 here, we begin with this one here. So this is the open buildings dataset, and here we are just seeing that buildings with the confidence here. For example, if the confidence is greater than 0.75, that will be considered as the footprints in the presence of footprints, or there are some buildings, or there are some constructions. And if the values are greater, smaller than 0.75, that means the buildings are not there, or we are considering this as the low confidence, and these are being added as the layer. So this is the code doing that things, and again these are added as a layer with the colors and with the name of that layer. Then we have the land cover samples, meaning different points with different properties, and the colors are being assigned to each feature properties based on those values here. So we will get the class, and then we are listing the colors, and then we are providing the style, and inside this style we have the colors. So each point will have the different colors based on their values. So here we are mapping that function, and then we are adding this as the layer. So we are displaying the points in the layer. So this might be nice way while we want to display the points in the layers. Then here we're doing something very nice. We're converting the land cover sample feature collection to an image. So this is the conversion of the points to the image. So all the points will be just made into an image. Very nice. So this is being done by dot reduce to image. So the properties will be the class. So so we have already provided different colors to each point based on their values. So this will be a nice way to do that. And then we have this reducer, ee.reducer.first, and all these are being renamed as class. And then we are adding those land cover bands to the post establishment composite. So again, adding that land cover sample feature collection as the new band to that post median composites. Here we have the chart bands to be visualized, and then we have this everything being printed just to see if that has been added as or not. And then again we have this UI.chart.image.by class. So what this function does, it plots the median band value for each land cover type, and we will see that one. And again this is being printed in the console. Then we have this index bands, and here again we have this UI.chart.image.by class, and this is plotting the median values for each land cover type. And then again this is the same repetition of the previous codes, and this is the section 2. And here we see in the layers, the first one is the settlement boundary. We had seen this earlier, difference image. So this is the one we were talking in this section. So this one is the high confidence, where the buildings must have taken place, and this is the one which has the low confidence, less than 0.75, and these are the land cover samples with different colors. And then we have the settlement boundary again, and we see here something in the console. We see the two charts. The first one is the Van values the reflectance along the different bands. So we see the smooth, some reflectance in the higher reflectance in the NIR, higher reflectance in the SWIR. But again, all these are very simultaneously going. But this is the chart that the function resulted. And then we have this other chart showing the different values. So here, for example, NBR is being shown for different classes. Similarly, we have the NDVI values being shown for each class or each land cover, and NDVI for each class. So this is the section 2. Now we go to the section 3, and in the section 3 we are creating the different points here. We begin with the creation of the different points. So this value 500 is being assigned for this variable. Then we are selecting the NDVI from that post-median composite, and we are doing this dot sample, scale with 30, number of pixels with 500. And what is this? It is just doing the in a general sense, this is selecting the NDVI image, and it is creating the 500 points from that image, from that NDVI image. So that is the thing here, and we're adding that as the layer. Then we're doing this other thing here with some constants, with some values are being assigned to different variables. The first one is the number of clusters, maximum iteration, set values, and here we're doing this ee.cluster dot this WEKAK means. So we are doing this unsupervised classification from that NDVI image. So we have the number of clusters to be created as 2, maximum iteration as 5, and then the seed value or the value. So when we rerun this, so we will get the same result. And then we are training from that samples that was created earlier. And then here we are doing the clustering by dot cluster with the clusterer that is being created, and then we are adding that result as the new layer. And then here we have this kernel being created. So I think the chapter related to the kernel is in the other section, in the beginning chapter of this book. But here we're just creating the kernel, and this kernel tries to kind of cleaning any pixels that are somewhat ambiguous in nature. So we will see that. So here is the k-means result. So this dot focal max and dot focal underscore minimum are being provided with some values inside. So we will not discuss this one here, but this is very nice. We will surely go through this in the future videos. But here, in a sense, we are just going through the codes. And here, finally, we are doing this dot these two vectors. So we got the result. Now we kind of make those layer into the vectors. And then we are again adding this as the layer. And here, again, is the outline of the study area. And then we are just seeing this, or it says the intersection of the k-means polygons with the UN is your system boundary, and returning the intersection area as the feature property. So we are just finding the area which is common to both our analysis and with the main study area that was given by the UNHCR, and that has been sorted to select the polygon with the largest overlap. and we see something like this here. So let's try to go to the layers. So the first one is the settlement boundary. Then we have these 500 different samples being created, and then we did this classification. So we see this 1 and 2 layers, and then we have the clean. So we did that kernel there. So this is the this is just the cleaning of that ambiguous raster layer. So in the output, in the original classified image, we are seeing this kind of image, or the classified image, but once we do that kernel, we are seeing a little cleanings being done, and then we have this being changed into the polygon. So now this is the polygon. So here we see this polygon. So this might be the nice thing to learn, to make this classified image into new polygon. And then we have this settlement boundary again, and this boundary is the overlap between the settlement boundary and the result from the k-means classification. So this is the area that is being overlapped between the two different areas. So this is the section 3, and we go to section 4, and the last section is about calculating the area. And here again we're sending this as object. The first dataset is this one here, second dataset is this one, and the third dataset is this one here. So I'm not naming the datasets, but generally these are the 3 different raster datasets that deals with the population. And we are doing the visualization here, adding 3 different layers as the new layers. So we will see this quickly. So the first one is the GSL population. Second one is this one here, and last one is here. So these population datasets also comes with their own resolution, and here we're doing this dot projection, and from that projection we're doing this dot nominal scale. So this is the way to get the metadata of the dataset. In this case, the patch resolution, how finer are they. So this is being repeated for 3 different datasets. And here we are doing this reduction to find the population on that story area. So here we are selecting the population, renaming it as something else like this here, and by dot reduce region we are doing this mean of that raster, or trying to find the population. So this has been done for each case for 3 different population datasets, and these are being printed. So each time we are doing this dot set, each time the new property is being added to the original dataset, or the original save file. And here we are doing this difference between the settlement product and the UNHCR recorded population values, just to compare. So here we are doing this dot get GSSL and subtracting with the UNHCR population. So this is being done for 3 different data sets, and then we are printing them out, and we will see this here, what is being resulted. So the first one is the GSSCL, which has 250 meter, HRSCL 30 meter, and the world population scale 92.7. So these are the resolution of these population data sets, and we're also we're also seeing the values calculated or estimated by the different data sets. So here we see the first one is GSL, SRSL, and the whole population. So 3 different data sets are giving us 3 different numbers, and here we did the subtraction, and this is it. So there might be some more analysis need to do. So the book also concludes or says something about these things, about if the numbers are something else, how to interpret that one out, and if the numbers are greater, how to interpret that amount. So this analysis might also be useful in other cases. For example, if you want to predict the population being impacted by the floods or any natural disasters or other things as well. But this is the nice chapter. I try to go through this as much as possible. I hope this was helpful, and there are some assignments in this chapter, but if you have any comments, please comment them. So this much in this video. Thank you for watching.